share a link. Serious. Alright, so I think we're good. Alright, perfect. Alright, guys. So this is not too much of a big thing. Okay, so alright, good afternoon everybody. So now welcome to the Physicists Lab. So what we're doing is basically switching MAC addresses, learning and stuff, and we're going to do some IP address stuff related as well. If I have time, I hope I do. For those who are watching the YouTube stream, and take a look at it. Behind me is a PC that I booted up into using a micro SD. I use Ventoy, so I told I mentioned Ventoy before. And I did a VHD file with Windows Server. So I booted that PC up with the Windows Server running right now behind me. And I'm demonstrating, because I have some IP address and tools in there to see what you can get now. Technically, I can install Zoom on that, and I can actually join Zoom session with that PC and then demonstrate what will happen in it. Until I start to do IP address changes, and I just particular that you're going to lose connection from the Zoom. The only other way is to take I'll take a webcam and plug it right in front of the PC, and then you can see the screen. So I think I have a cam that's on the Zoom right now. Well, that way. Yeah, it's on the board. So it's on that's Zoom right now, recording on the whiteboard. So that's webcam. So I may, depending on the time, I might be able to take webcam, put it across, and you can see what's happening on the screen. I may have to get a volunteer to hold the camera. Okay, so basically IP address layers. Let's continue. So this is the network layout in the packet tracer. I used an older version of packet tracer to build this out, but I did that because I call it for backward compatibility, so I can use an older version of packet tracer. Why? I sometimes set the roots in the legacy system, I use that, so that's me. So it's a simple network, so you're going to see one plus student network. Let me just get my right. So you have student network here. And it's typical switches, and it's kind of mirroring like, and if you notice the IP address here, you may not notice the IP address here, but again, you guys are in this course, right? So you're supposed to be able to check the IP configurations of the PCs that are in this lab right now, and you realize that the IP addresses are actually the same net subnet as this network. So it's kind of mirroring the student network in a small subset, right? Not the PC names, of course. And then you have the PCs and the IP addresses. So the .1s you'll notice here in each of the .3, .2, so that's actually the fourth octet IP address. So it's 192.168.1.1, .2, .3, .4. There's server. I did not put an IP address in the server, not in the diagram, but when we delve into the packet tracer, you will get what we call explore and find out what the packet tracer is, what the IP address is. Again, I use packet tracer, and you'll have a background, blue background for this case, representing student network now. On the right hand side, and you'll see some pink box and something called shadow network. And the pink box below as well. So technically the pink, this kind of peach pink kind of color, will denote a separate network. Now, you ask yourself, well, what's going to happen here? Well, when I go through, you'll see. And this is going to demonstrate things like MAC address learning and hospital learning, and then things like broadcast domains. So you get into that at one time. So I'm assuming that you would have already watched that video I put online, right, from this person's CCNA stuff. Watch the other videos from it because it's he's actually done all the CCNA stuff, so you can check the videos for that. As phone guys, so that's pretty good to look at. I use this stuff to build out what this lab is, but I also extended the lab to demonstrate more stuff, because this was just focused on this MAC address learning and forward. That's it. I'm looking at showing you how broadcasting and IP address, and that's how this weak is going to be, because we did IP address anyway, we know how to place it. Right, so this is our client networks, and my other labs that I built out will also have these things. So it'll have the IP address in, the IP address, client mask. What I did not put was the interface. All of these will be FA0. Right, what I did not put is server. Alright, server 11 and server 21. And again, those will be, I did not do that, I should have, because server 21 is going to have two interfaces, just to let you know, that's spoiler, right? When we go into that part of the lab, you're going to see what's happening there. Standard IP addresses, mask is simple mask. What you notice here in mask in this second set of PCs, it's actually a class B network. Remember we talked about classes on Thursday, and they're using a 255.255.00 mask at this point. So that's equivalent to how the class B operates. So that's what they use. So again, rename and download the package tracer file. Right, so download and rename it, the ID number or something. So you could always have the original file as a backup. Right, and make sure to log into your network file account. So that's what you're doing. So main steps in this lab, we're going to, it's literally slide by slide. So you're going to see it happening here, and you could follow and see what I'm doing. Right, if you know what you're doing, you can go right ahead and follow these steps. So one, you're going to check MAC address tables. We're going to use the commands. This is when you check slides, I'm going to have commands showing how to do it. Because a lot of these things are just repeating the processes. We're going to clear the MAC address table. As the next step, we're going to ping PCs and servers. And then we're going to check MAC address tables again. So we're going to see what's happening there. Now, while we're doing that and pinging, I am actually going to demonstrate something called package simulation mode. If you guys haven't done it before, I'm going to demonstrate that. And I'm actually going to show you how these learning and these frames will be moving across the network when you do discovery. So that is how we're going to do in the beginning, and I may, as I go along the way, I may use it or not. So it's up to you not to go back and forth between real-time mode and simulation mode. And that's one thing package has over GNS3, is that you could actually pause the network at a point and then step through every single the activities going on. Like GNS you can't, it's all run. And you're going to pull data from this to use like a sniffer like Wireshark and stuff. Right? So again, check MAC address tables again. You're going to now, so once we do this piece here, right? So this is the main section here. So we're going to check PC servers, check MAC address, and we're going to use it, we're going to check on different switches on that student network. What we're going to do now afterwards, we're going to go to the shadow network. I'm going to connect, we're looking at the devices and that's what I mean connect. So we're going to check MAC address tables again, same thing, we're just repeating the process up to here. The next step is that we're going to configure and connect PC25, and I'm going to show you where it's going to connect to. The slides later in that, as you go along, the slides will show screenshots of how the connection is going to happen. So I'm going to connect and configure and connect PC25. And we're going to do something, and I'm going to check MAC address tables again. So I think, hold on. Oh, sorry, yeah. This part here connect to shadow network. What I should have been more specific, I should say connect student. Right, student to shadow network. Right? So these screenshots will show you what it looks like. I think the camera is in. Alright, I just need to change the video settings for the camera original ratio. Come on. Oh no, not original ratio. Take out that mirror, take out the mirror. Alright. So we're seeing anything what camera is. That's the wrong side. That's okay. Can I rotate? No, that's not good. That's not good. Right, much better. Right, so we're going to check server 21. So the server 21 is on the shadow network, and then there's some configuration. We're going to do some more things, check MAC address tables, And then a nice question to ask at the end: how do we get one network to communicate with the other network? Some of you may know the answer. Some of the slides from Monday or Tuesday, you check those slides from lectures 2. They will have something called routing the answer, right? But how we configure it, that's what we're going to do. So we're going to demonstrate how one server can connect to both networks. That's what's going to happen. So, right, so first things first, we're going to check MAC address tables. Right, so let's move across, packet trace across here, there we go. Right, so what we're going to do, and you're going to see this here. The same command, we're going to switch 11 and 12, we're going to do show MAC address table. So that's what I said, let me repeat, and I'm hoping to finish this soon so I can get show you the other things in the other PCs. So again, PC, this guy is CLI. Right, so if I try to show MAC address table, it should show it, but I like to privilege that code in case it doesn't, but you could actually do it out. Right, so show MAC address table, we only have one value here. We have VLAN 1, and we're going to do VLANs shortly, so after we do IPv6 next week, I'm going to start doing VLANs as well. So you're going to see where VLANs start to come into play. You're going to see a MAC address here, type dynamic, ports gig 0/1. So we ask ourselves, who is this port, who is this gig 01? So when we look back to our plan, we're seeing here, look, gig 01, right, and if you don't believe it, because power and also over the link itself, and you see pop up. I just put the labels in here to make it easier to identify. Right, and it's easy placement versus packet trace versus labeling. So gig 01 is saying that there's something here, it picked up on this interface. So what happened is that it learned this MAC address from gig 01 interface. Now it does not know who owns this thing. It just, all it is doing is interface to layer 1 to layer 2 mapping. That's what this true MAC address table on switches. So switches does this. Right? There's no, if I do a show, I think you have it here. Right? And there's nothing here, so we don't have much information there. So the main thing is this. So what happened, and as I demonstrated before on the videos, it learned some kind of MAC address to learn from this because a frame came across the network into the switch, and it came from a device with that MAC address. Now, which device has that MAC address? Well, we don't know. I mean, if you look at the cover, you see. So the MAC address on that table was what? Again, 3BB5. Go over the PC. That's a 7503. Nope. Right, this guy's a DDD3. Nope. 371B. Alright, no. So all of these guys, none of these PCs, and when I read the MAC addresses on the right hand side of the that will pop up there. I'm not seeing it there. So, and if I will, who's this? I don't know. We'll find that out later, right? So when we investigate. So we cannot, so it's picking up a MAC address that's coming from this side of switches, but it doesn't mean it's not matching up any of these devices here. Right, so again, as a network administrator, you're going to get devices like this coming up, and you need to know why this is happening. And we're going to do an investigation why, right? So switch 12, so let's go back here, switch 12, we're going to do the same process, so MAC address table. Right, now this switch learned something here, learned EB19. So we're going to find and learn from the gig 01 interface. So again, we look back, who's this interface? Right, it's gig 01, it's this interface on this side, on the right hand side. Right? It learned something, where is this? So you have to ask the question, well, where did it learn it from? So let's move over each PC and see the IP, right? So let's go back to the MAC address, make sure we have the right one, good. Right? EB19, so I can move this to here, I open, I can also run, put it. Yeah, so I don't want to do that too much. So EB19, just keep that in mind, that's what we want. So I click on this. Right, the maps on the right hand side is B1, BA, 0C7D is the other one, that's root map, that doesn't matching up. Let's remember it's EB19 we're looking at, BA7C is the end, and D3DC. So those is not matched up. So none of these PCs in this case are actually being broadcast across there. Right? They are frames from frames. Therefore, what we could see, and that could be a system question. They could say that no frame. This has not learned a frame that has been originated from these PCs. Right? That's what happened here. The switch has not learned that. So it hasn't learned from has received a frame that originated from these PCs. That's one thing for sure. Right, so let's continue. Well, we're going to ask the question, okay, well, who owns these frames, right? This is another device here. What you can understand is that the switches, so I cannot deviate a bit from the lab. So we're going to do some more investigation who owns these frames. So I actually am going to own this switch. And do a show version. It should have something here, right? It should be able to pick it up from this switch here. Right, so now, no, it's not going to fit. Right, there we go. So, what I did, I went to the switch. So you know that all the most devices, once the network should have a MAC address. So I did a show version, and it has a MAC address here. Right? But when I looked at it, I remember this is switch 11. So when I come back to Packet Tracer, and I look at it, I'm still looking for, I'm still looking for EB19. I'm not seeing EB19 in that CLI, right? So I come back here. This is not EB19, 2C01, so it's different. So this is not just MAC address switch, so I'm sure where this is from. So what I did now, and this is from knowledge and from experience when you do this, right? You can't just all of a sudden pick this up just so somebody, you have to actually go through it. Cisco does not necessarily teach you this directly. You have to learn how to do this. What I did now is that, let me find out what's the MAC address of the interface itself. And there it is, EB19 0902148 EB19. And let me just make sure that's the right one. There it is. Okay. Right, 0902148 EB19. There it is on the other side. What did it pick up the interface? The MAC address of that interface 801 across there, so it picked that up. Right, that was Lance, I don't know why I did that, but that's what happened. So that's what that should do, and it's vice versa. So now we know where this MAC address is originating from. Remember, in the realm of network kit, they always have a device that owns a MAC address. Right, once it has a value, there's supposed to be a device. In this case, it's the ASIC belongs somewhere in the interface. And there's a high chance that you could find out where the information is showing, right? So even though switch 12 discovered it, we went into switch 11 and actually found out who was the one that originated of this thing. So we learned that. So now we put that to rest. We know, okay, great. We know where this information comes from, so we know that everything else should be consistent. So next step, let me just do a quick check in simulation mode. So in the lower right hand corner is simulation mode. And there's a whole lot of protocols that you can actually filter. So we just add the filter. So once you click simulation mode, it's going to pause the Packet Tracer. And it's going to show you what frames that you could have, or what protocols you could filter. So we're going to click edit filters. And my focus is LAN stuff. So right now we can move with DNS. So I can uncheck these frames. I don't need to see these. We don't do routing yet. BGP is in one course. And you know that there's no DHCP server, no HSR VMware. So we're going to take these off. We don't want to see that. Right, we just want to focus on something called ARP and ICMP. So again, you go ICMP is the thing, ARP is the ARP request. So we know who owns the IP, right? So we're going to see this happening. IPv6, we could take all this off, but we don't have to worry about IPv6 because we're not doing IPv6. It may see something's happening, but which we could leave that there. This now, however, miscellaneous. So we have a whole lot of protocols that we may have to end up coming out. Now, the cool thing about the course, we're going to be learning maybe DHCP, we're going to do EIGRP, OSPF, RIP, not B, so BGP, HSRP, maybe DNS is what you're going to do in this course. But when we finish this, you're going to know about these protocols. If you haven't done it before, you're going to learn all that. V6, same. Some of these things you're going to learn, not all these protocols. I think like RIP and next generation might deal with it. Might deal with OSPF V6, we can see why we do that, right? And the Naval Discovery Protocol, we will talk about it, we may not look at it, so you can check it out. Let me see, EIGRP V6, same thing, so ICMP V6 and DHP, so we might be able to touch some of these in the course as well. Now the miscellaneous, ACLs, we're not touching this. CDP, Cisco Discovery Protocol, we're not touching this right now, that's at the end. FTP, no. HTTPS, IoT, not in this course, neither one. LLDP, later on, we'll deal with it. LLDP and CDP is kind of similar. One is Cisco based, one is vendor neutral, or generic NTP. So we're going to take this off, not really as SCP, as we call it, SSH, no. VLAN trumpet protocol, we'll deal with that later. Bluetooth, for sure, no. Dynamic trumpet protocol as well, we'll deal with that as well. Not this, IPsec, no. PG, port aggregation protocol, we're going to deal with that later as well. Not PPP, this is LAN, not REP. Simple mail, not so much. Planetary protocol at this point. Should I not? No, I'll take that out. TCP, yes, I'll keep that. TCP, UDP, yes. CAPWAP, this is wireless, so take that out. EAP, that's an authentication, take that out. HP, take that out. LACP is equivalent, it's similar to PGP, so that's trunking stuff. Link aggregation, sorry. NetFlow, take that out. PTP, no. RTP, no. Simple network management, no. Syslog, no. TFTP, no. USB, no. So in this thing, we took out all these protocols that we don't want to see in this case. So we should be good. So we'll take that out. And as I said, here we might be doing about these, if not a third, not half, maybe a third of the protocols here. Right, cool. So the first things first, we're going to do a ping operation. Sorry, clear MAC address tables. Even if we clear it, what's going to happen, then those entries are going to show back up again. But I'm going to do the clear operation, so we'll see how this works, right? Right? This is the same simple process, right? Right, so this is where we reach a point of there's no unrecognized command. So clear is not recognized in regular user exec mode, so you have to go enable. And that's the reason why I want to enable. Because there's certain operations that you cannot perform in user. Things like changing equipment information or something like clear MAC address table. That's actually very important command in terms of MAC addresses. You don't want your search to be clear MAC addresses. You don't want any user who has access to just change that. You need someone who's an engineer and to do that, right? So now we can do clear. And you can do clear space question mark and look at this. We have all those things we can do now. Clear MAC address table, and then we go back to show, right? It cleared for now. It might pop up in a while, depending on what's happening with switches, right? So clear, repeat the same process in the other switch. Enable, clear, right? Show MAC address table, good. Alright, sorry. I'm still in simulation mode. Hold on, I have to go back into real time. Right, see, I cleared it. So the reason why Right? So the reason why it didn't show up on the is because the net was paused, so there was no traffic flow, nothing. But now I went back to real time, I did a show, and I got back the MAC address for the interface. So like I said, you keep clearing, and look at the other guy, same thing on the other side. So the switches are still going to be sending some kind of communication frame, and they're going to pick up one another, and they're going to report. So this is something that we can't avoid that in this case. But that's okay. Right, now we're going to do something operations. So before I start, we're going to do, actually I'm going to do one thing operation first, let that happen, we're going to do show MAC address table. And then I'm going to do go into simulation with that thing. Right, so I'm going to do a thing. So from PC 11, so that's this guy here. Right, so I'm going to pick 192.168.81.2. Right, so it's working. That's fine. We expect ICMP with it. So we can go back to our switches. I'm going to do one time. Right, I'm going to show MAC address table. I'm going to see some interesting things happening. Right, show MAC address table. So first things first, I'm going to go through it in the simulation mode afterwards. So what we just did here, we did .2, right? So what happened here, PC11 ping.2, which is PC12. So the frame, and we will do it in simulation mode, it should have tried to do an ARP request to find who's PC12, and it should have sent an ARP broadcast, right? So what happens, send an ARP request to the switch, it might go to the others, it will come back to here, and then PC12 will respond and come back, and then it can actually be pinged. So it will just basically localize. So based on that, should only have two interfaces, and the interface is listed, right? Right, so if you look at it, the gig interface is already there, if you know, and then there's two interfaces on the list. One is FA0, this BA7C, and then 81BA. So what's happening here is the two pieces, one is pinging to the other, they need to know the MAC address, the switch is going to do it. So what the switch did is learn FA02 has this MAC address, and that should match up the PC who belongs to who is on FA02, right? So if you go here, FA02, right? So let's look at this is here, FA02, that's PC2. So confirm that PC2 has a MAC address, and then with BA7C. So let's hover over PC2 and see if we see a BA7C. Right? PC2. Sorry. And BA7C, you'll notice it at the end, MAC address BA7C at the end. That's it there. So the switch is showing the information, and we were able to verify on the PC. Right? So the switch is important in terms of collecting information, and it's using that to know where to send the frames to. And it matches, right? And the other one, let's move over to PC11, and we see B1BA, right? Sorry, 81BA. So that's the last end of the MAC address there, PC11, right? And let's go back to the switch, right? 81BA, and that's it. Fast and then 01 is important. So it learned that PC11 came from this port. So remember how I told you how MAC address are learned, so when you watch videos, that's how a switch builds up the MAC address table. And the interesting thing as well, you ask yourself, learn PC11, how in the world did it learn PC12? Why? Because PC11 needs to define what PC12 is going to do a broadcast, right? The mere fact of the ARP request happening, the switch will learn PC1. When PC12 responds, the switch is going to learn that MAC address response, that frame. So that's how the switch will start to learn. And it's learned in simplicity. In fact, in terms of doing your algorithms, think about it like that. So that's how the algorithms for that switch how to do it. So you could do the same thing too. Instead of trying to apply intelligence on AI and all these things, trying to figure out how to learn something, if you're getting things coming towards you, you can use that to identify where you learn it. In fact, the dynamic routing protocols and all kind of do the same thing too. They learn routes by where information comes from, those ports. And that's how the RIP will use the distance vector and all this to learn it that way for the information coming to them. Yes, they do send out more update packets out, but that's what they do. Right, so now we're going to do a simulation mode. And now we're going to actually do the next ping operation. So we're going to ping from PC11, we're going to ping 81.3. Right, and that's 81.3.3 that should be PC13. So it's going to have to do a request two switches out. Right, so that's PC11. Now because it's simulation mode, if I press this, it's going to look like it's frozen. That's because it's the packages have stopped the frame. Look what's happening here. Come on. So there's a few things happening here. One, the ping is an ICMP, and the ARP is another one here. So we have two different protocols to look at. Right, so in the ping operation, simple stuff, we have the US, and this is why I got Packet Tracer, why I tried to do certain discovery stuff, but you have to delve into the stuff together. Packet Tracer at least does it in a nice format. So look at this, the in layer is, because it's outgoing, it's an outbound layer. Layer 3, the header, the source IP is itself, the PC 81.1, which is PC 11. Destination 81.3, which is PC13, right? So that's it. Layer 2, right? So this is a unicast. So what's happening here, there's nothing else in here. If I click around, there's nothing else. Why? Because the ICMP has not started officially yet. It has to wait for an ARP request, because this thing is, we don't know who in 81.3 is, because the PC does not have that information. Remember, everything here, it needs no via, it does frames. Frames is the most commonly denominated between most of the devices, other than IP addresses. But frames is most commonly denominated with, switches, PCs, and routers, because of all layer 2 stuff happening. So it hasn't started yet. If I go outbound, you're not going to see much information. You only see the source and destination IP, which is what we want. But that's it. What we will find out is the ARP. ARP now, it's where we contain some more information. ARP is where it starts. So if you look at it, and layer 2 now, right? So remember we just click on layer 3, the ICMP is layer 3. Now we click on the ARP, which is just layer 2 stuff, right? So basically it's a layer, that's a header. Look at the source here. 81BA, that sounds from the PC, right? 81BA is a PC, and look where the destination is, LLS. So this is basically our broadcast frame. We have seen it in the slides, right? This is our broadcast frame. So now, an ARP, in most cases, so when an ARP happens, an ARP is more or less a broadcast frame. Inside the frame, it contains some information here because that's an ARP. The ARP protocol is the reason why it has the IP address in there. Why does it have layer 3 stuff? Because the ARP protocol is a protocol, and it's doing that exactly. Taking this out and sending it out, say here. It's going to go to somebody and see who owns this IP. Tell 81.1, right? Who owns 81.3? Tell 81.1, right? And then at the bottom now, the fast internet is going to send out the frame. This is where your bits and bytes is going to happen, right? You're not just bits and bytes, but your electrical signal. So technically, the physical layer is beyond binary data alone. Physical layer also is electrical signals and cabling. So the physical layer consists of like 3 different things. IEEE standard will have all of this in there. Right? And if you look at outbound PUE details, we just covered everything. So we have the destination address, which is all Fs. Much more grammar, too much. Then source frame, source MAC address, sorry. And we don't know who's the destination MAC. So we've seen source everything, but we don't know who the destination. We don't know who the target MAC is. Target MAC is all zeros, so it's going to go to everybody. And this is the IE is this. So this is the ARP, outbound PD for ARP. It's going to say, well, I don't know who it is, so it becomes a broadcast, but tell, and this is where the target. So the PC who owns this IP is going to respond, based on the protocol. just a thing. If you have a device with all zeros as a MAC address, that shouldn't exist. Right? That means that it's unknown. You can't get access. There's no device with a zero in a MAC address. So it's kind of like a ghost MAC address. You shouldn't see that in your network, but sometimes you do because of how broadcast work or your broadcast not doing too well. Right, so we already described what's happening here. I'm going to do a step through. Right, so this is basically before ICM even continue. There's a lot of things happening first. ARP is going to be going through, right? So it's sensing ARP. So ARP gets a little more complicated. So we're looking at this, it's actually coming in at device switch 11. So we click on the frame, or this ARP frame, and we're seeing a few things. One is at device switch 11, but it came from PC 11. Right, so we get some more details into this. So we know in layers, which is where it came from PC, we're going to see the PC source MAC address, the source MAC address, which is this. Interesting enough, the first switch is going to learn this. That's what it's going to do. If it didn't do it before. It has this, and then it's also going to show the fast set at 0 and receive the frame. So that's the information here. The out layers, right, so it's going to see here, 81A. It's going to try to not much, it's kind of look at it, it's almost the same. Because nothing states, not much state change. Right? What's going to happen here is that this interface is sending out the frame to F01 and GIG01. Now, this switch has about, this might be a 24 port switch. And all of a sudden, I want to know why newer packages inside system is only on two interfaces, right? It's a coincidence. No, it's not. The reason why packet traces is going to put this in its frame, naturally it's going to send the frame on all interfaces. Remember that's what ARP will work, that's what broadcast will work, right? If it doesn't does, it will send it out through all interfaces except the source, right? So what's happening here is that all the other interfaces are disabled. They're off, nothing is connected. So if nothing is connected to these interfaces, why should a switch need to send out to those interfaces, right? You don't. And that's the reason why you hear now say it's going two interfaces sending out, which is good. So let's go say, well, we have inbound PD details there, you get do the breakdown. Right? And outbound PD. Right? So something, the monitoring is the same. And our broadcast happening, so it's not going to change. Right? So now let's do the next step through. What happened there? We just see two things went out. Right, so we're doing some investigation, and once it reaches there, we're going to, once it reaches the PC13, we'll actually go, we're going to go to every time, and we'll go from there. So I wouldn't worry too much about going into more detail and explaining this. Right, so you guys have a good explanation of something. Right, so we have two ARP frames. One is going to PC12 and one is going to switch 12. So let's look at two PC12 here. Right, so they give some examples. Look what's happening. They give some explanations here. You can take a look at it and explain, right? So the received frame as normal, knows who it came from. Right, so it also, because it's an ARP request for CL, well, who owns the this IP, right? 81.3. PC12 is going to say, well, it's not me, so I'm not even bothered to respond. What I'm going to do, yeah, receive frame, but I'm actually our process drops the frame. So you see the steps here. That's why like a couple packages they actually explain it into here. Right. There's nothing here in the out layers because it's going to come in. Inbound PD details is just the same thing. All F's, you're going to see MAC address came from, source IP. So right now PC12 knows the MAC address of PC11 because of this. And in the real world, yeah, that's what happens. The devices will learn the MAC address of other devices. As a matter of fact, if I go to PC12, desktop, it should show it. Oh no. Oh, did it just? Oh my god, did I just clear out table? Oh my god. root, I just clear the out table. Yeah, and that's fine. I'll put another piece there and we'll see how it goes, right? So I just clear. That's just a one in thing. So let's continue. Right, so there's an operation here. Can I cancel that? I don't think I could. So this kind of this is the next step. Alright, move to the next frame here. Right, so this is another frame. So it's on the other. This came into the switch. Came in, switch interface, received the frame. Now it's actually going to send us out to other frames, right? It's going to send it out to Ethernet 01, 02, and 24 because all these are connected. So we're going to do that, and then go to the next step. Right, set all three of them. You notice a few things happen here. Two of them discarded the frame because it didn't match. PC13 didn't discard it because it belongs to this. Right, so it actually received this. Now, what I can do, I can actually go on PC13. Right, I should be able to show off this file here. Right, so it learned 81.1. And this, if I did it before it received the frame, it would have been empty. Right, but because it received the frame and it knows who this is, guess what? I know where it came from. Because that request came in. And I know who the physical address is. Because it came out as well. Right, so what's going to happen is going to ask PC13 to say, okay, who wants this IP 81.3 and say respond to PC11. That's what's going to happen. So he's going to do a response. And you can see it happening here. No, this is different. Oh. That's the frame here, one of these guys. Right, so two things. PC13 is going to respond and say who's the it's going to respond, say, okay, this is my frame. Sorry, this is my address here. But it's also going to put in my MAC address. And it knows what's PC1. That's the thing. So that's what's going to happen. And then you have the receiving frame, the outgoing frame, and it's going to go. So now, let's go back to the switch. Right? So that's the next thing. The switch knows where to send this frame. Because the switch op table is going to send this. Right, so I'm going to go on the switch, and the switch is going to say, okay, well, I know where it is because my op table, my MAC address table, sorry, is knows where its destination MAC address is, right? So actually, I can go to the switch level, and I do a show MAC address table. Right, it knows where to send this to the destination. Or I think it's the A7C. Right, and this is the equivalent to include this MAC address. I think it's DDD3. Right, learn that from the other switch. So that's how it is. So that's how the switch is going to do this. Right? And everybody else is going to drop the frames, the other from the out request, right? Come back up to the switch, and now, after now the ICMP is going to go across. Right? It knows where it is. Now I'm going to send the ICMP back. Right, so you see the ICMP is here. Now I'm going to go out into real time and let that run. Right, and there it is. 81.3 is done. And if you go to the switch, all of them start to build up the MAC address table is going to grow. So before it was like, look at this, it was 1 and now it became 3 and now it's now 4. right? Switch was growing its MAC address table as well. So look at that. Just by a ping operation, the switches are starting to go in MAC address. So therefore, somebody's asking how you get a switch to learn MAC addresses. You just ping the devices on the network, right? Or if you ping a device that doesn't have doesn't exist, it's going to go out and it's going to respond. Right, so we did this, we're going to ping 81.4 and then 81.254. So that's going to be from PC 11. Ping operation, again, this is happening really fast behind the scenes, so you can notice the R happening here per se. And then 254. Right? And then we go back to show MAC address table. Our PCs now load all these MAC addresses now. Right? Because we forced it to. We pinged every single device. Now it's supposed to have. Let me see. So switch 11 is supposed to, by theory, we know it has 1 by default. So switch 11 is going to know 1, 2 MACs here, and it's going to load the others the other side, right? So 13, 14, and the silver. So it's going to load 1, 2, 3, 4, 5, and the gig 01 interface, that's 6. Right, so 11 is supposed to be 6, 1, 2, 3, 4, 5, 6, that's correct, so it's within our thing. And what's happening is that most of them, only 2 it learned from local ports, the others it learned from switch across. So 4 of them here, 1, 2, 3, 4, it learned to gig interface, that's what happened. Right, so we did that. Check MAC address tables, we're going to check clear MAC address tables now. Well, we didn't show, so let's do clear. Right, and we're going to do a clear as well. We do a show to verify. Right. So, next we're going to connect to Shadow Network, but before I continue, we can take a break now, and we will resume about 4 minutes past 1, right? Alright, we just mute. We just pick up the chat screen. That's cool. And we're back. Alright guys, so what we're going to do, we're going to connect to our shadow network. And we're looking at the diagram here. I didn't see any it didn't show any unfortunately it didn't show any what interface to connect with. But we're going to go with a simple interface connection, right? We're going to actually use the gig. So I'm going to use a crossover between switches and switches, which we did before, right? So I'm going to connect to the gig 02 from one switch to the gig 02 of the other switch, and it's up. So it's orange right now. So that's basically span tree, which of course will go through that process. So it's actually a listening and learning state, listening and learning right now. Learning and then listening and forward. So it should go into forward. Once it goes read, it's in a forward state. Right. So as that's happening, let's go on to the next slide. Right, so we're going to check MAC address tables again. We may see one of the switches might see more on another MAC, as switch 12 will see a MAC. Right, and then we're going to start pinging clients here. Yes, right. Do the same thing over. I'm not going to go through summation mode, we're just going to ping all the clients. Right, so first things first, let's do show MAC and then ping clients. Where our packet tracer is here, so it's green. Well, we could do an enable. Right, gig 01, a bit fancy. Right, so this is up. Right, gig 01, nothing too fancy. Straight, should have shown on next interface, right? Because we connected this other one here. So let's go to switch 21. So this is our shadow network, as I say. I don't want to call it rogue, it sounds more. This sounds too not the right term at this point. So let's call it shadow. Let's right, so there's something here, gig 02 and gig 01, and there's something gig 02, and gig 02 is actually EB39 and EB39, and gig 02 does this port, right? So it learns something on gig 02, which should be this switch. So let's go into switch 12. I'm going to run this again, right? The fact it learned one side, the other one is going to learn the other one. But what we're going to do, we're going to do a show interface and we're going to do a gig 02. Okay, that's the interface connected. And what it was EB39. I'm seeing here, let's make sure. That's switch 21, right? EB39. Right, so it's matching up. So what it's picking up, which is cool. This switch 21 is picking up the MAC address of switch 12 and it's matching the interface. So we're good. So it's speaking up. Now me, somebody's doing any shadow network and stuff, well, guess what? These switches are starting to learn this stuff on the shadow network. Which is good, so it's not really a shadow network anymore, because the switches are learning it. So you as the network engineer, or it's going to say, hey, my switch 12 is seeing something in this interface here. I don't have in my design something connected to this interface. And that's why as a network administrator, you're supposed to engineer, you're supposed to have your design statically set up, right? Don't keep it dynamic all the time. If you're relying on always updated information, you're going to have some problems because you're going to have something updated automatically, which is not supposed to happen. You need to have a baseline. Baseline is like a snapshot of what your network looks like at this point in time. And the best baseline happens when you have a normal operations, like your lab duty, not busiest day, but a normal day. Right? So let's say you pick it up on Monday morning or Monday afternoon and you do a baseline like that. So that will get you an idea what the network is because everything is operating normally and you get a snapshot. That's your design diagram. So you usually say, hey, I'm seeing something coming up here. I did my scans now and I'm seeing this additional. This is not compared to my baseline, this is not supposed to be here. So you as the administrator figure this out, say, hey, something's going on. And the reason why I'm doing that is because this sharding network could be actually doing operations, and I'm going to demonstrate that now, what's going to happen. So we're going to do ping operations now. Let's see what I'm right. So we're at ping PC11, so this is what's happening. Normal, everybody is running normal stuff. We can go back. Right, 81.1, that's itself. 2, 3, 4, 5, 4, right? So it's pinging itself, everything is normal. And let's consider that your student network is happening right now. 3, 4. 2, 5, 4, right? So we're pinging this as normal. And we can do show MAC address tables and stuff like that if we want. So let's go 12, switch 12. And we get all the devices. So it's 6 plus 1, 7, right? Because we just see that, remember 7 on big 0, 2. So 1, 2, 3, 4, 5, 6, 7. Now we're getting 7. So it's predictable still. Remember, interesting people asking, okay, is the network predictable? Yes, it's predictable. At least in this package's environment, it's predictable. But the moment you add more devices, predictability is more difficult. It gets more complicated, but there's more information. Because there's more information happening. But it's still predictable, at least this situation here. Right, let's go to the shadow network switch and see what's happening here. Show MAC address. So it's picking up some more. It's picking up some more frames here. There was more MAC addresses. The thing about this is that 81BA, looking familiar, I think 81BA might be PC 11, right? So let's go back to the thing and see that's the case. Right, 81BA. So this switch and the shadow network picked up PC1's information. PC11, sorry. And PC11 did not even bother to ping anybody else. What ended up happening, they picked it up because of an ARP request happened. And I'm going to go into PC12 and do a ping operation, and you're going to see an ARP going span across the entire network. All I did was plug in one PC, right? So, and that is why you have PC11. Well, PC11 pinging P21, but we're going to not touch that just now. We're going to do 11. We're going to go PC12 and try to ping PC12 to ping PC3. So it's something that we did not do before because we're going to force an ARP. So go PC12, let's run an RA. Well, all it knows is somebody there. So all it knows is that, right? So if I go to a ping 192.168.81.3, which is different. Before I do that, let's go to simulation mode. I want to get into the simulation mode. Right. Start. Right. PC12. Now the ARP is going to go. Next step. Switch 11. Next step. Switch 12. ARP is going across. Waiting is going to happen the next step. Switch 12 is going to send to all active interfaces except incoming, right? So it's going to be 4. Look at it. It went right across. Look at that. Switch 21 received this ARP request now. Now switch 21 is and this ARP came from who? PC12, right? So switch 21 now has knowledge of PC12. Guess what? This is going to send out to all. Switch 22 now learns about this ARP, and now switch 22 learns about PC12. Doesn't matter if these PCs rejected, right? All these X's, doesn't matter. Right now, at this point, PC21 and PC22 has knowledge of where the MAC address of PC12. And I will run it and show you. I should show MAC address and it's supposed to be with PC12, right? Right? It learned PC1 already, and I think BA7C is supposed to be PC12. So let's go back here. Right, BA7C, PC12. So look at that. Just by connecting this, and we go back to root time. So just by connecting that network, look what happened. That ARP just frame just propagated across the entire. If I had more switches chained along, you could do that with this experiment. chain along about 4 or 5 or maybe 10 switches, chain them along. And that arc is going to work for us. Now there's a limitation on how much chain these chains could do. There's an old rule, I can't remember the rule, I think it's 7531 or something like that. Something called segments and repeaters and all those things, right? So those are the days with hubs and stuff. But now switches, you can add more devices, but it's still a limit to how much you can chain. Right? Now you may think, hey, I can chain switches down the line from one building to the next building and hop along. Yes, it can do it, but there's a certain limit. And this lab will be fit. When we do spanning tree, we will add those, we will do those chaining. So I'll basically chain about 3, 5, 10 switches down the line, maybe 20, and see what happens, right? So I'm thinking that we will route them, but we're going to do that in spanning tree. Okay, so now, so PC12, if we do an RA, now we'll learn about 81.3, and the interesting thing about it is that the other switches, let me see DDD3, and let me see the other switches know about this, right? Right, so these switches did not know who's DDD3. Didn't learn that, right? Because all PC13 did is that it actually responded to the request of PC12, sent the PC switch 12, and switch 12 already knows where to send. Also, this is the thing about switches, is that it knows, so it didn't, switch 12 did not have to rebroadcast this frame to everybody. If it did, all the other devices would know about it. Right? So it did that. Good. So we go to the next part, where we're saying PC11, go to ping 172.16.81.1. Now before we do that, let's take a look and see that PC 81.1 is PC 21, right? So let's move our mouse over and we're going to see 176.81.1. Alright, so the IP address is set on this PC. And we're going to go from PC 12 to try ping PC 21 on our shadow network. And say, hey, let's see if we can do this, right? So we're going to go ping 172.16. Whatever it was again, 81, right? 81.1, right? So this guy is just copying some 81.1, right? So quick question, will this work? Oh, sorry, 81.2. Is that 81.2? Oh, before I touch that, that's 81.2. 81.2, PC 22. Right, 172.16, Quick question, will this work? Will we be able to ping? Yes? No? Put it up in the chat, guys, if you want. No? No answer. No? Okay. You all hear me out there, right? Yes? Good. Will this work? I mean, if you follow that, it won't work. Right? Right, somebody say, sorry, broadcasting. I will take off these Zoom sharing stream, right? Hold on, let me just go back to more OBS to fix that. Let me remove this. I think it's this one. That's not the right? Okay, so somebody said it wouldn't work. Any reason why it wouldn't work? So you could run the command and it wouldn't work, right? But what's the reason why would that work? Guys, we're in Tuesday class, right? You're in Tuesday class, right? Why?
Switches go out. And you need to power out them between it because it's two different networks.
Right, so the main thing, it's two different networks.
Yeah.
Right? Because if you look at the IP address that you're looking at, it's going to take it, compare it to this mask, and realize, hey, wait a minute, this is different from my IP address compared to my mask. And so because it's different, it's going to try to send the default gateway. That has not been configured. Because there's no default gateway, it can't send that packet out. That's the natural order of how IP addressing works, right? You can't just fake that and tell it, oh, well, I know it's supposed to be here, that's in my shadow network, right? I know it's there, but no, that's not how IP address works. It's going to compare the mask and say it doesn't exist, this doesn't exist in my network, I'm going to go to my default gateway to get to it, right? So guess what? At this point, every single PC here in the student network, PC 11 to 14, cannot see the IP addresses on the shadow network. And that's the reason why I call it a shadow network, not a root network. They cannot see it because they're all on different IP address blocks. The IP address network all together. They cannot. Right? And that's what I'm demonstrating. That's a demonstration of what's happening here. I'm demonstrating now. So you ask the question now, is the shadow network still a viable network? That's good. And that is what the rest of this does from PC21 ping those IPs, right? So I demonstrated here that this did not work, right? But it will work here. Right, so from PC21, I'm going to do 81.2 and 255 and 254. Right, 172, 116.81.2, and there it is, it's pinging. I wouldn't go through the backtrace stuff, the simulation mode, but it's pinging. And I'm pinging another one here, 255 and 254. And it's going to work. I intentionally did that 255 and 254 to show you that that's the end range of that network. If I go beyond that, it's going to be the 256 does this, so the 172.617.0.1 would be the first IP and wouldn't work. Right now, I think I didn't do another one, but I can do that later. Technically, I can actually put down IP address 172.617.255.255.0, and that'll actually be a valid IP because of how this class D is, and 0 is a valid IP. Right, so right now, our response from 21 is showing that yes, we can actually access this network. And in fact, 255 and 254, I can actually go to PC 23. Go into the desktop mode. Go into my web browser. Just wait a few seconds, it takes so long. Good. So I'm going to hit HP 172.168.255.254. And we are actually able to browse this IP address. So in all intents and purposes, HTTP, which is our application layer protocol, we can use. And this is 25254, that's the server here. It's an application layer protocol, HTTP. From PC 23 was able to go through the switch and access the server. So the shadow network is all working normal. It's a normal network. You can actually put file servers and everything in here and running. And look at that, they're all connected with a switch here. And yet the student network is not seeing it. Right? Interesting enough, who is seeing this? The switches are seeing it. So as an engineer, you come and check and say, hey, so I go to switch 12 and say, oh well, the switch is supposed to not have knowledge of it, right? So show back to the table. And switch 12 is not seeing everybody else, not seeing the other guys. Why is it not seeing everybody else? Because the frame is not even reaching to the switches. So all intents and purposes, that's what's happening here. So I demonstrated the traffic flow, a separate network altogether can actually exist in another new environment, and you would not even know because the IP address block is different, and they are accessing that. And look at that, even switch 12 didn't. Look at that, we were able to access servers on 21 and 23, and switch 12 did not. And this is the boundary, right? This is the one that parameter. He's supposed to know stuff, and he doesn't. So you have a whole network doing operations, and the switch doesn't know about it. Right? So you as an engineer need to know that, understand what's happening here. And I'm teaching you this to go there when you go into your network, you do any engineering design. You make sure you look for those things, right? So it's not like this is very practical. Now, reach a point here. We check MAC address tables, we're going to clear, configure. So last piece here, we're going to do a configure and connect PC25. So this is where we're going to throw up something different. So a person who wants to be continue living in the shadow network and you don't want to be discovered, well, they shouldn't be doing this, but we're going to do it anyhow and we're going to see what's happening here. So this is where we see red flags start to come. So this is PC25. So let's say you were able to have physical access to the network drop, like literally on the table here, and you take your PC25, in this case your laptop, and let's say I'm going to connect it to switch 11, I'm going to do 11, doesn't matter, it's 24, 24. So I connected it, and this is like one of you guys decided to plug your laptop and take the drops into the network here. Yeah, that's really one reason why you don't plug into the network here, use the wireless. Right, so I just demonstrated this thing. So PC25, load them up, and configure. So we're going to go to desktop, IP address, IP configuration, and I'm going to set some IPs. Now, what is the IPs? We're going to put it up, what is listed here, right? So 172.1.6.81, that's our shadow network, .25. It's automatically filling because it's class B, and that's more or less it. We're going to close that off, that's done, and we're going to command prompt. Right, configure and connect. We do the same thing else. So this is the screenshot of what it is. All focus really this, right? So desktop, IP address, I'm going to set it here. Nothing else. Right, so this is what it looks like with configure. Connected, so this is what somebody plugs their laptop into the network. Right, so for PC25, we're going to ping PC21, Silver 21. Will it work? Right, I'm going to do a show MAC address before we go. Before you do that. I'm doing that to see if anything fancy comes up. So PC25 didn't any traffic through. But the switch didn't pick up anything yet. But now we're going to things are going to change the game. So question, will this work? If I take it from PC25, ping these two IPs, will it work? Yes, no, you guys sleeping? Will it work? No? Some say no. I really had a hole in them. No, put them after that. You got to. Alright, so somebody said it will work. We have some polls, others say we have a camp saying it will not work. You know, if you follow the lab, you can actually test and see if it will work, right? Why would it work? Why would it work? You will not have one, right? Right, it will work. Right? Yes, so it's the same network, right? 255.254. Right, so it's the same network. Now, I'll let you guys do the packet trace and stuff, right? So we know what's going to happen here. In the packet trace, right? What's going to happen is that it's going to send a request, ARP, to this switch. And this switch is going to forward the ARP. So the switch is going to do what they do normally, send the ARP request, they're going to forward. They're not going to say, hey, who are you? I don't know who you are. No, they always understand protocols. They want IEEE standards, all that, ISO sites, it's going to follow that. Switches do what they told what they do, right? So switch is going to do the work and send it out. So the ARP literally went from PC25 to switch 11 to 12. And each switch is going to send out that request to all the PCs, right? So if you think about it, the PCs are going to drop it because this is an ARP request for something that I don't know about. I'm going to drop that. And that's the thing about it. They're going to receive it but drop it. It's going to go all the way across to switch 21. And I think it was IP.1 was what it was, so PC21 will receive it. It will also send it to client 2. So every request, so this thing got broadcast. And that's what's happening. Once a broadcast happens on one device, that is going to propagate to the entire network. Every single switch, once it's connected to layer 2, that's layer 2. So layer 2 is going to propagate across the entire network. So that's basically one broadcast, not just IP address, but one broadcast domain, so everything is connected. The moment you put a router somewhere in between, it's going to block that broadcast. And then that's also because of different networks. So once you have a different network, you must have a router. Routers block broadcast. But what I'm showing you is that you can actually have broadcasts happening on two different networks. So you do a router, separate networks. You can still have two separate broadcasts happening here. And if you come into switch 11 and you do a show MAC address table, look what happened here. What we did before, we is going to learn something. So, once, and this is a PC on that switch. So now, switch 11, has knowledge of more devices here. In addition to the, I think it's, right. It learned port 24 now because of that broadcast. PC25 sent out a broadcast. So it learned that, which is good finally. So now your baseline, this is going to be different from your baseline. This doesn't look normal. It learns something from gig 01. One of those are the switch from gig 01, but the other two may actually be other devices. So 3BB5 is familiar, so we can mouse over that and see who's that. So gig 01 will be somewhere along on all these. So 3BB5, let's see. D3, so that's the last one, no. 753, no. ED76, no. So we have to move across here now. No 8103, no. B396, we look at 3BB5, right? 3536, no. 7046, no. Right, so there's no 3BB5. I am suspecting, and that's this switch picked it up. So we had a found who picked up from gig 01, none of these guys. And I don't think it's this switch interface either. Right, oh, sorry, 3BB5. Okay, sorry, picked that up there. My mistake. Okay. So it's 5386, right? Okay, so this is known, we know this. But I know these. 5386, I think we picked it up somewhere. We did, I think, this one. Oh, 8103. Right, so 8103 is this guy here. We picked them up. So now this switch ended up learning another PC here. It learned PC21. And the other one is 5386, so let's see who's 5386 here. No, the B3, 70, 5386, look at that, it picked up the silver. Come to that silver just now. So this switch starts to learn about other broadcasts. All this, remember, like that's picking up. So that's the good thing about the switch, picking up all the broadcasts on this network. And even with this shadow network. So even though PC25 is communicating very along the shadow network, the switch now, switch 11 is picking it up. Right? Which is good. So you as the administrator should say, hey, something's up, I need to investigate. I want to know who's 24 connected to this. Find where the port is, and that's why you map it out to the real world, as in physical, until you do the lab. So I would know that port 24 on this switch is a drop somewhere in this table here. And I will look for that drop, and I will check it and see if something's connected to it or not. And then I trace that to something about the device, because somebody didn't end up having a Raspberry Pi literally stuck on the table here. Power it up and connect to the network, and you wouldn't even notice that it's running. Or for that, so these are the high small devices in here, and connect to the network. So we will monitor and stuff like that. So what we would normally do as an engineer later on, we will, and I will show it when secure, we normally ports that are not used, we shut them down. right? We take them off. So if you connect, nothing happens. So that's what we do to prevent that from happening. Right, so now we did this. So we're going to check macro tables, we're going to check Silver 21, we're going to configure Silver 21. So I'm going to check this and see what we're doing. So I already clicked Silver 21, that's where we are. I'm going to configure, I think, and there's a few things I want to show you. In the interface, there's actually two interfaces. And that's the reason why I took a Silver. Silver, I was able to add more next to it. So at first at 01, if I click that, factories is kind of slowing down. There's a 5386 MAC address. And this is 255 to 254, so that's matching up what? That's on the network. Everybody's seeing that. There's another interface called GigaEthernet 0.1. It should have a MAC address, DE73, but there's no IPv4 address. And one GigaEthernet, check it back in the network. We only see one cable connected from this server, right? So what I'm going to do, I'm actually going to put another IP address in here, right? So I'm going to configure GigaEthernet 01 here. I'm actually going to put an IP address. Guess what? I'm going to put something into the network, right? 81.200. Right, so 192.168.81.200. Mask is on autofill, that's great. And I can close this off because it's set. Yeah, it's still not right, so close this off. Right, so you'll notice the two lines coming from Silver now, two links. All that is one switch, right? We didn't do much in this. We just put two links from Silver to that switch in our shadow network. And now, what was the next step again? From Silver 21, you're going to ping everybody in the list, right? All our 192s and some of the 172s, right? So that's Silver. Oh, I closed on Silver already. Yeah, I'll go back now. Right, so I'm going to click on him. Oh wait, I didn't connect yet. Oops. I didn't configure the IP. Desktop, I'm going to go to command line, so let's come here. Well, I forgot to configure the second link, so I'm going to take a cable, connect to the server, Gigabit Ethernet 1, and then connect to the switch. I'm going to put Gigabit Ethernet 02. So look at that, this server is going to have two net connections to that switch. Let's wait till it's orange to go. Let's give it a few seconds. Actually, let me go into start pinging. So I can start pinging 92.168.81.1, right? I'm going to ask a question, will it work? The answer is going to be yes. Why? Because it has an interface, active interface, that is going to check and say, is this mask matching with one of these interfaces? Right, so let me before I do that, let's do an IP config. So it's going to look at this. This has two interfaces now. And if I do a ping, 192.168.81.1, I'm going to get a response, right? Why? Because that packet is going to go through this interface here. And it's going to go through that switch, that channel switch. And from that channel switch, it's going to go all the way across to PC1. Right? If I do 2, same thing. So now I have a device on my shadow network that can access both my shadow network and my main student network. Right? So you can literally have, so essentially, I actually have, I think I'm going to wrap it up. So now I essentially have two networks running here, more or less almost parallel. But one set of devices can't see it, the other set of devices can't see it. But I have one configured that can see both, which is the server. Right? Because I come and take the set server, hey, ping 172, right? 2.16. Not itself, but 2, no, not 0, no, 81, sorry, 81.1, right? So he can ping both 192.16 states and he can ping 172.16. So this server has access to both networks. Now you may ask the question, okay, well, yeah, that's a good idea, you can do that, all these things. When you go back to the switch, 11, how much MAC addresses this thing is going to learn? Well, it might learn much, but it's supposed to learn 5386, right? So it know about this. Switch 12. Right, learn a lot of stuff here, and it's picking it up all on the gig 02. You have 1, 2, 3 MAC addresses learned off gig 02. One of them will be at a switch, it'll pick up 2 devices. Right, so you'll notice that some switches will have MAC address information of some things, other switches will have MAC address of everything, right? Because what's happening is that these PCs are not communicating directly with every other PC. So if I take PC 525 and he's communicating with only child network, PC 25 has to ping everybody in that network, right? So I have to ping 181.1. So this PC 25 has to go and ping all these or communicate with devices in all shadow network, right? .3. Well, yeah. In order for switch 11, sorry, to learn more, right? So the only way switches to learn more about these other networks is that devices have to start communicating. But regardless of that, it's two different networks. It gets unwieldy to have the server dealing with everything, right? Because you want, sometimes at the end of the day, you want one PC to communicate with a PC on the other network. And that comes back to the question which I had before. Check your MAC address tables and then come back to this question, right? How do we get one network to communicate with the other network, right? In this case, we want PC 11 to be able to communicate with PC 21 in this example. How we do this, right? The best way is to put a router in between. But just remember, if you put a router in between, literally physically here, you're going to block the broadcast. It means that PC 25 traffic will not be able to get through, right? So we'll have to work out a way to get that to happen. And interesting enough, VLANs are going to use a solution for that, and I'll show you how that happens, right? When we deal with VLANs. So that wraps up this lab here, and I'm actually going to demonstrate. And well, I can't really demonstrate really because these PCs, PCs here that are still. Now, some are going to reboot it, some still going to base. If I try to reboot them into the flash drive, they're going to take forever. So the PC like I have configured behind me, let me see how I do this. Yeah, the best way is I needed 2 devices, so I don't have to be able to do it, but I can actually try something. So I'll just move this camera here. I need somebody gotta hold this up. Sorry, you guys see that good? No? And again, like a few more cm here. Alright, that's the max I can get. You all see that good in Zoom? No? Kinda? Should bring that PC closer. Alright, well, I'll let this. Oh, somebody's still seeing. Okay, good. Okay, so I'm gonna pull this chair up here. And that's gonna fall down. Alright, let's see how we do this. That's gonna tug.
need tape. Maybe you can help hold up. Okay, maybe you could hold it up. Alright, so I just have somebody volunteering to hold this up for me. Alright, so I wouldn't go into Zoom or anything, so what I'm going to do, so this is a PC that I have set up here on this. This has booted off a live, I don't know about this. So I have booted up a live Ventoy on a Vista VHD, so it's like live Windows running here. The cool thing about it is that I'm going to run some software. So that's what I don't have in the lab here, but maybe later on I might, maybe not, I'll ask them to put it in. So this, what is happening, this is piece of software, is you could check it out, it's Colosoft Mac Scanner. So again, this is a part of your network toolkit, so you guys could actually go and get your network toolkit, just get these apps. So I might list these apps in. So the unfortunate thing about it is that if you try to install it in a corporate environment, the endpoint protection might pick it up and say flag it as a potentially unwanted application. Even Windows Defender might pick it up like that. So what you will look at is, that's why you have a separate PC for that purpose. Let that be your device to do all these things. Right? Let me see if I can bring this closer to me. How close I can get to you, boy? Better? Full screen, right? Okay, so it automatically picked up on the top part of the software. It automatically picked up the network here. Or the focus not. Or if I move around, the focus better. It's focusing. So if I push it back, it'll focus. Focus better? No? Yeah, at this point? Alright. Interesting. Okay, cool. So you can see the IP address up here. Alright, so I'm going to change the screen resolution to something funny. I hope it will work. Oh, I could do this. Let's see. Better? Blurry? You're kidding me. Alright, I'm going to join the Zoom. I'm going to install Zoom, I'm going to join it, right? Zoom download. And I'm going to share my screen with this right? Install it. No, not Windows app. Download. Alright, okay, let me just put this back then. Alright, so this camera is going to go back. I'm going to join the Zoom and share the screen, right? I'm going to stop this share. Right, so the Zoom will have this, but I'm trying to get the meeting info. I don't know why I can't get a meeting info. Alright, there it is. Alright, so 9. A few seconds there.
Right, nice. Okay, so what I would have normally done, right, I would have normally, if it set up a different network, 172, 116 over this. So I use this software called Mask, and you guys get online, get it downloaded, and then you just start. Well, actually, I'm going to do some settings. Scan threads. Right, so we don't have nothing else, right? So we just click start, and it's going to treat the entire network. And scanning every single IP address that's happening. You know, you put in all this out because of this. If I do a short arc, right? So the arc table and PC showing I should have done it. Right? So this the entire scan. And sometimes as an engineer, you'll find network admin, you'll want to do the scan of the network to get a baseline, find out device. Two things are the 300 resolution to the PC's name. So how is the PC's? If I see something off of the ordinary, right? So right, so I know these items, I love these, all these. So anything here out of the ordinary. So in most cases, going out of the ordinary, these guys are talking. And this is where I want to do investigations to find out. Most of these are matching on printers and stuff like that. So there's a printer. Don't know what this is, the 28, so I can figure out what that, then I do my research. These are Microsoft devices here, so there's a chance that these are going to be virtual machines. Dell computer here, I don't know. So now I can actually find out, okay, investigate and see what are these devices. They're not matching. And that's me as an administrator, I will go and find out what this is, right? Now, so the next question is, how do I know if there's a rogue device in my network? Shadow network. How can I tell from this if there's a shadow network? So it's going to be difficult. You will have to end up putting Wireshark to analyze and pick up things that are not part of your baseline. So what you can do is you do Wireshark and you compare it with what matching the IP addresses that you know. And then you see whatever is the difference, you start investigating those. Identify which switches they belong to. As you will see, when you do the switches, you see which MAC address they belong to, right? You know where it is and you know which port to pick it up. And that's what we do now in network as well. We discover a report in the case of a PC number so and so is reported on network. And go and investigate. So they will send out a notification to the LAN and still investigate. So we pick up something happening here. In fact, we picked up a PC that was 7 years ago. I was doing a heavy torrent. So we're doing about 500 cases in the torrent over the weekend. Nowadays, we do much more. But the torrent is about 500 days and we picked that up. So there's a solid, like a research computer, but it's not, so the standard out to the industry. So when I identified the PC name, identified where it was, and I knew which one it was, based on the MAC addresses and report it to. So once we did that, we found out and collected the information to investigate. But we didn't do I knew who it was, but I didn't escalate it to the point of, because it was an harmless thing, we removed the content and the block torrent. So our firewalls block torrents, our firewalls block peer-to-peer systems, not because of all those things. So we're trying to do VPNs, so we block all that. Because of use of bandwidth beyond that is going to be reaching our user acceptance or accept what we call fair use policy and stuff like that. Right? So this is what I will do. This is one, I will do MAC addresses. Now, next popular app I will use. I've installed, what is this? Sorry. Oh no, these apps you can use on any Windows PC. Right? Once you can install it, you can use it. So just pick it up. This is another under ID standards Java based. Again, this is going to get flagged by when you're in the corporate environment, you can flag it as a POA, potentially unwanted applications. You can restrict it also. But it does that because of what it does. But you as an engineer will have that in toolkit, so that's why you have a live disk that you can drop your stuff from, right? So I'm just going to show you some stuff here. We put down a lot about this app, but of course scans as well. So it gets more interesting and more dangerous. I'm going to do a live post, respond to things, and I'll do stuff. So it's going to do scans as well, and it's also going to do call scans support data. So all these things is to tell that hey, there's a web server running on these, right? It's supported, right? There's one 443 as well. You could add more ports to scan, but of course, the more ports you add, the more it takes to scan, right? Because each thing takes time. So you could do how much ports in addressable ports on a PC typically? Well, not typically, theoretically. How much ports can be addressed on a PC? Or be used on a PC? Or per IP address? Okay, how much ports? It's about 2 to the power 65,000. Right, so that's how much ports that can be open on a PC, either both incoming and outgoing. So most cases you will never reach that amount. But in the case of our campus, you will reach that amount because we have thousands of students going through our internet. And any connection that goes out will have ports opening out, going out. And our firewalls have to deal with all of those ports, manage all of those ports, so it adds up. So our firewalls are going to have to deal with it. So we're going to run out of ports because of, if you have 10,000 students and everybody's not doing Tor, let's say somebody's doing about 5-6 different browser windows, and each one is a different connection, that's a different port opening up, right? And your source port is going to be like about 10,000, 20,000, 50,000, it's going to add up. And that's just you only with, let's say, 20, 50 ports. Multiply by 1,000, you're going to get 50,000 ports easily. Double that again, 2,000. You're going to get 40,000 plus. So we're going to reach the cap. So what we do is that this is the WAN ports. In terms of network address translation, we actually do port overload. We do multiple IPs going on the internet and do something called overload. So it's going to map out IP address to port mapping. So that we could go up to at least 120, maybe 65 by 3, 180,000 connections that could afford. But each of those needs to have an IP address to work with. If we only have one IP, it's not going to have a problem. One workaround trick we might do is to put like another gateway in between. So we have consult all connections coming in different devices, all that go to one gateway device, and let that NAT again. So we do down NAT, and that will help. It might not help too much because every connection still has to be connected, has to be monitored. So that would be more items. And most organizations, 65,000 is no one enough. Yeah, that's good. So all of these, this is giving me IPs, is giving me ports that we open. Now, there are some devices, I think, right, I haven't done it here yet, but there are some devices that have firewalls that block ICMP pins. So I would not, this is going to area security, and you guys can experiment with that. In terms of picking an IP, so the question is actually a good philosophical question, something you could try out. If you have a firewall that blocks ICMP pins and you ping that IP, does the switch actually pick up that MAC address of that device is blocked? Right? Does the switch pick that up? Because the firewall is blocking the ICMP. But the question is, does the switch pick up that? I could still forward it to you, but you wouldn't respond. Right? So does the switch do it? Theoretically, the switch could do it, your device could do it via an RP. Because you can know the IP address, but you can't ping it. Right, so that's something that you guys could try out, but you'll have to actually have, that's why you need to do physical, because factories doesn't do firewall. And you'll actually have to physically set up your Windows firewall and then block ICMP and then run pings. So I might try it out and see if we could do that later on in course. If you guys want to try that, let me know. Might as well go for the different things you want to try out. Pick the top ones you want and then you
Right? So these are the next two tools you can use. These are in the software. I like software. I have running on I have Google standalone. And I have exceptions when you're going to be familiar and embarrassed to figure it out. Alright, 201, I think Alright guys, thank you very much. Any questions? No, Q&A, email me. So this covers land, this covers some pieces of land.